Hello, welcome back. This is Mini Rust in Rust, episode 28. My name is Andy. We're writing an interpreter that can interpret code that looks like Rust code, which is normally a compiled language. And I think I've decided two things about this, which none of which we'll deal with in this video. It's just my thinking. Assuming I keep going with this for long enough that we have to deal with stuff like that, I want it to be able to interpret any Rust code that you could find in the wild, like not unsafe and not stuff that is has inline assembly or anything like that, but any kind of normal Rust code. And I want it to have the same semantics as that normal Rust code in some sense. As in, I want the same answer to come out at the end, I guess. But I want it to have automatically collect your garbage. So I think what I'm going to do is copy what Swift does, which is have reference counted, like clean up when you've run out of references type stuff, and not care about, like, if you make loops, that's your own problem kind of thing. And because it's valid Rust code, if the Rust compiler's checked it, then that will mean that things do tend to get cleared up at approximately the same time they do in real Rust code. So all the references will kind of by definition not be referring to it any longer when it gets to the end of the owning block. So at that point, it'll get cleaned up. And so, yeah, okay, I'm just waffling away, but that's the ambition, to have something that feels like Python or something like that, where you just create variables and they stick around for as long as you need them, but the cleanup code, if there is any, so like the drop implementation happens when you get to the end of the block that owns the thing. That may or may not make sense. But that's my current plan. All right, so back to what we're doing today. We have this example bit of code, which is a bit like kind of a snippet of code that looks like Rust, and we're trying to make it, well, eventually we want to make it run and actually calculate the factorial of 3. In this case. But what we're doing before we get there, we just want it to parse. So it already lexes. The only lexing we just do is like this less than or equal sign and this while, which is a keyword. But now we need it to parse, and then we're going to need it to type check and then evaluate, but we're going to do that later. So if we unignore this test, which is like our guiding test that we keep on re-ignoring because other bits of it go wrong, and then we run the tests, we'll see that this doesn't actually parse yet. We're nearly there. We've done a whole load of stuff to make that while loop parse, and that's what we did last time. But but there's a bit more work to do. And what we need to do is handle this type of construct. We need to handle things where we're modifying a variable. We're also going to need to handle this I plus equals 1 thing. And I guess since we're handling I plus equals 1, let's change this into x times equals I, right? And then they're kind of similar to each other. And we won't have to deal with the x equals whatever style. We'll just do times equals and plus equals for now. Just to simplify this example a little bit. So we've currently got these things, which I've called assignment statements, and I feel like I should now call them declarations, because although they do assign, in this case, they do assign a value in there, really what they're for is declaring something. So let's start by renaming these things declarations. And then once we've done that, we'll start doing, I guess we could call these mutations or something like that. So, where are we going to rename that thing? And why am I making my life harder by going around renaming things? Because I always want things to make sense. and be right. Otherwise, I get lost and confused. So here's one of the places where we use the word assignment. Let's just search for the word assignment as many places as we can. Okay, so there's a type of syntax node called assignment. Let's rename it. Not like that. What did I say? Declaration. Oh, but it's not just a declaration. It's not a spell declaration. It's a variable declaration. We're going to have other types of declarations, I guess, like struct declarations and things like that. Am I starting to regret this? Let's call it an assignment. It's okay. It kind of gets declared and assigned. And sometimes you don't actually assign anything, but we don't support that yet. All right. So back off. Let's go back to what we're supposed to be doing, which is this thing, which we're going to call a mutation. So we need to be able to parse. Well, I guess we need to be able to lex the times equal. I think we can already lex the plus equal. So let's start by saying I want to be able to lex the times equal as well. So we should have some lexing tests for plus equal somewhere. Surely. Well, do we lex plus equal? I thought we did. Maybe I forgot to test it. Yeah, so we've got plus, and when we go into operator, then if it's a plus, we immediately stop. So we can't lex either a plus equal or a times equal. So our example is, all right, so that's the first thing we need to do. We need to be able to lex both of those things. So let's do it. So let's find some useful lexing tests. I think we can definitely lex less than or equal. Yeah. So let's do something pretty similar to this. Let's call them mutation. Let's just call them mutations. So it would be something like my variable, which we'll call HJ, just because I don't want to call it X again, plus equals 3. Or let's say 39. And we'll also have another example. We'll say JF times equals, and we won't have any spaces, and we'll just say, we'll give it a more complex expression, like something like that. So these don't actually have to like compile and run, they just have to be things that we can lex. So this should lex into 3 tokens. The first one should be a symbol, which is HA. The second one should be, now this is not really an operator. What do we call it when we just have assignments? Do we call it an operator when we just have the equal sign on its own? We definitely can lex an equal sign on its own. Here we are. Okay. So keyword let symbol X, and then the token is called equals. So in our case, it's going to be called. It's either going to be called plus equals or something like that, or it's going to be. I think I want to say it's like a mutating equals. Is mutating equals? We'll start calling it mutating equals. We'll see if we can think of a better name. All right. So where were we here? So it's a symbol HA, and then it's a mutating equals or an update. All right, we'll just go with mutating equals. And that starts at 5 and goes on for 2. Does it start at 5 really? 0, 1, 2, 3. No, it starts at 3. Right? I think. And then it's going to be an int, which starts at 5 and goes on for 2. So then we're going to have another one. This is going to be a symbol. And then a mutating equals, which is times equals. And that goes from 2 and goes on for 2. And then we're going to have a symbol of HA, which starts at 4 and goes on for 2. And then we're going to have a plus, which I think is an operator. The operator is plus, and that's going to start at 6 and go on for 1. And then finally, we'll have another symbol, which is the HO, which is going to start, hang on, does this really start 6? Yeah. So hang on. No, it's alright, it's fine. 4, 5, 6, 7, starts at 7. And then this one starts at 9. Something like that. Alright, so we hate the name mutating equals. But I think plus equals and times equals are so similar that we will give them just one name between them. And that's the best name I can think of at the moment. So it's going to go, I guess I'm going to put it near operator because it's a bit like I'm going to put it near equals because it's a bit like equals. Put it here. This is just a construction function for making a token with a kind of mutating equals, which doesn't exist yet. And yep, so that's going to look like this. And yeah, these literals, we actually refer to the string, so we don't need the to copy that literal into here, but it's really convenient to have it, so we haven't got rid of it yet. Alright, so there's a type of token called mutating equals, which is different from equals, and it's something like a plus equals or a times equals. So any errors? Yeah, so there's only one place where we match on all the possible different token kinds and we do something for each one. So we need to add one for mutating equals. So that's weird. Why is there no equals? Oh, there is. It's here. Alright, so what are we doing here? We are trying to create a leaf token from a token. So yeah, mutating equals is never going to be a leaf token. So this actually gets handled the same way as equals, just to say mutating equals is not a leaf token. I shouldn't have a comma. And that's all fine. But why are we not getting more compile errors? Oops. Don't know. Alright, so let's run our tests. Surely they're going to... Obviously, they're definitely not going to pass. Are they? Yeah, they're not going to pass because we haven't actually done the lexing of these symbols. We've just said this type of symbol can exist, but we've never said how you actually make one. And this is our example test. So let's comment out our example again, or rather ignore it, so it doesn't confuse us, and go back to our lexing test. And our lexing test fails because we're expecting a mutating equals, but it's finding a plus and then an equals and treating them as separate symbols, because we haven't done lexing of a plus and then an equals as a single thing. So here's exactly the place. So not exactly the place, because exactly the place is up here. So when we are lexing things, we get the next character here, and we do a match on that character, and if that character is a plus, we find ourselves here. So up until now, plus always meant we were starting an operator, but now it might not be an operator. It could be a mutating equals or an operator, but only in two cases. So if it's a plus or a star, it might be a mutating equals or it might be an operator. So we actually need to break these two things out. So if it was a less than sign, it's definitely an operator. Now it might be an operator with more characters in it, like less than or equal, but it's still going to be an operator. But if it was plus or times, it could be an operator, or it could be a mutating equals. I hate that name, mutating equals. But it kind of does express what we want. So, integers start with a digit. What are we going to say? Something else here. Plus equal, etc. Plus, etc. Plus or similar. Let's just say plus. Could mean a plus equal or just plus. Whereas less than is either less than or equal or just less than. Either way, it's an operator. Yeah, that'll do. Fine. So we need a new thing called operator or mutating equals. It's going to work a bit like operator. So let's just make a function and call it operator or mutating equals. Takes in the first character, which is like plus or times, and then gives us back the answer. So if the first character is a plus or a star, then I guess, no, like everything that gets passed in here, we know we need the next character. So get the next character. And if we had a next character, do something otherwise. If we have no next character, then we finished lexing, and this was just an operator, right? So, yeah, so we can do the else part, just like, yeah. So, in this case, so in that case, it turns out that it's not valid because we don't actually handle less than or equal yet. I mean, we don't only handle less than, we only handle less than or equal. So this is misleading us. In this case, if there isn't a second character, there are no more characters. So this is just an operator. Because both plus and times, they can just be operators on their own. So we're going to return something a bit like this. How did I do that? Let's try again. So return an operator But here it's going to be a token count, which is going to be like the character 1, I guess. But as a string, how do we turn a character into a string? Oh, we just do, yeah. char1.toString, easy. And the position is going to be 1 long from 1 before. So yeah, if there's no second character, it's just a normal operator, we just return it. Otherwise, we've got a second character. So now we're going to do something very similar to what we did before, which is create a string out of the 2 characters we've got. This won't be op, this will be, I guess we're going to call it ME for like mutating equals. No, that's terrible. Let's just go for S for string. I can't think of anything better. And then we're going to do a match on that thing. Like so. And we deref here, by the way, to give us a str instead of a string. So S is a string, but if we want to match on strings, that's really annoying. So we want to match on strus. So if we do deref of a string is a str, because a string is like a smart pointer to a bit of UTF-8 memory, which is what a str is. So if we've got plus equal, then in fact both of these, it's even simpler. So it's either plus equals or times equals. Both of those are like valid, and the alternative is that like it's invalid. So we need to do something if we were given something we don't understand at all. But if it's one of these, it is valid. So we're just going to return something that looks like this. I'm wondering whether we even need a result here. Yeah, we do, because we're about to return an error. Good. Okay. So in this case, it's going to be a token of type mutating equals, and the string is going to be is S, and it's going to be 2 bytes long. So it's going to look something like that. There should be a semicolon here. That's why it's moaning about that. And now we just have to handle the error case. So if we got the second character after our plus or our times, it should, and that character means that we haven't got plus equals or times equals as our kind of final token, then whatever came after the plus or the times is not a valid thing to come after a plus or a times. So what does that mean? We're either going to say this is an invalid token, or it could be just like say a 3 or something like that. And that is allowed. So actually, I guess this isn't even an error either. In this case, what we're going to do is put back the token we just were given, which I think is self.chars.giveback. We'll give back char2, and then we'll return this thing. Same as this. So there are no error cases, but I feel like in future there might be, so it's probably okay to still have a result here. Should be a comma there. Yeah, okay. I think that's right. We're not handling errors, so let's definitely, before we even run this code, let's write a test for the other case. I don't know what is plus minus? Is that just a plus and then a minus? So it's fine? I wonder what Rust does. We've actually got a bit of Rust code that we can try out here. So what happens when we just say 3 plus minus 2, like that? Oh, no, yeah, it formatted it. I've got automatic code formatting turned on, so I can't make it run those two together. But the fact that it formatted it like that means that that is actually, it says that is valid. Can I be bothered to turn off automatic formatting? What if we did plus times? That's not valid Rust, right? Oh yeah, well that was, okay, there must be something we can do here. There's plus plus, that's not valid Rust. And the question is, how does it complain about this? It says, oh, it's got a very specific, oh goodness, it's got a very specific error message for when you typed plus plus, which is cool, but means that I can't figure out whether it thinks that's one token or two. What about plus underscore? Yeah, no, anything that comes after that plus, it's just separating it out. Okay, it's fine with it. Right. I think this answers my question, which is that, although it has special code for looking for plus plus. By the way, one more thing to check. Can we do plus 2 like that? Okay, so yeah, right. So we could also have special code for dealing with plus plus. That would be very nice, wouldn't it? Because plus and then another plus, it doesn't make sense anywhere, I think. So we can fail. So what that tells me is that this is, basically Rust is every time there's a plus and then something that wasn't one of these expected things, Rust is like, fine, that was just a plus, so we're going to do the same. So there's not really an error case we're going to test. It's just a case where the plus is treated as being on its own. So we're going to do lex plus and star followed by, or like immediately followed by something else. I just want to check this works properly. So we're going to simplify this down and just say plus minus. We're just going to say plus minus, right? And then in this case, we're going to say plus or times 4. And this should parse as just a operator plus of length 1, followed by an operator minus, also of length 1. And this should parse lex as operator times followed by a number. What's that? Int. Which starts at 1 and goes on for 1. All right, let's see if those tests pass or whether we've completely messed this up. Okay. Lexing failed because the minus was not expected because we don't handle minuses yet. So that isn't going to work yet. So we could just, no, we don't want to test for that. And the other situation we did something wrong, which is that we said that right, so let's fix that too. Where was that? 484. So this should be one further along here. That makes sense. All right, so minus on its own is not yet understood. So our easiest thing to do might be to just handle it. Or we could try, let's just try plus x for now. No, it'd be really good. What about plus plus? So I think this will work, and then later on we can handle plus plus as a special case. Yeah, okay, that worked. So let's just have a little to do in here. To do specific warning that plus plus is not a valid operator in Rust. But for now, like when you see plus plus, we're going to lex that as a plus and then a plus. But if we see plus equal, we're going to lex that as a single thing called mutating equals. So, have I forgotten to make a commit again? I have. Jez is going to be so mad with me. I'm so sorry, Jez. All right. So how can we split this up? I think we can. All right. Let's try. So we're going to make last video stuff into one commit. There's all to do with returning units and things like that. Blocks. Renaming that. We did that last video. Not that change. We did that this time. Not that. That's all new stuff. This looks like... no, that's all new stuff. New stuff. New stuff. New stuff. Here is our old stuff that we did last time. Blocks and things like that. Yep. Allowing units to exist as a thing. Blocks to exist as a thing. Not mutating equals, that's new. Yep. Units. Blocks. Units. Blocks. We did lots, didn't we? Alright, so this is allow while libs. This is last time. Apologies if you didn't watch the last video. To have bodies. And what we've done this time is allow, so lex plus equal and times equal. So I think that probably makes a video. We got a little bit closer to making this stuff parse. It doesn't parse. Let's just try it. I'll show you. It doesn't parse yet. Because whilst we can now lex times equal, we don't know how to parse code that contains times equals is in it. So that's what we'll do next time. I hope you enjoyed, and see you next time.